Good morning, class! How are you today? That's great! Before we proceed to our new topic, who can recall our topic yesterday? Yes, that's correct. Our topic yesterday is all about factoring. Now, before I am going to introduce our new topic, let me review our objectives. At the end of the lesson, the student will understand the basic solving problems involving rational algebraic expressions. B. Solve literal equations or formulas involving rational algebraic expression. And C. Apply the concept of solving problems involving rational algebraic expressions in real life. Now, before I am going to explain or introduce the topic, I have here an activity. This activity called Decode Me using alphabetical letters. This activity consists of numbers, and these numbers have a corresponding letters. You must answer this activity in 10 seconds. Your time starts now. Okay, time's up. Who can answer the activity? Okay, that's correct. The answer of our activity is solving problems involving rational algebraic expression. Based on our activity, what is our topic for today? Okay, very good. Our topic for today is all about solving problems involving rational algebraic expressions. Now, what is rational equation? A rational equation is an equation containing at least one rational expression. Rational expressions typically contain a variable in the denominator. For this reason, we will take care to ensure that the denominator is not zero by note or restriction and checking our solutions. Verbal and algebraic expression. A. Translate each verbal phrases into an algebraic expressions. Number 1. 10 added to twice in number n is equals to 10 plus 2n. Number 2. In number x decreased by 3 is equals to x minus 3. Number 3. Twice in number z divided by 4 is equals to 2z over 4. Letter B. Formulas are equations that state relationships between quantities. These formulas can be translated into verbal sentences. First, P is equals to 2L plus 2W. It can be translated into the parameter of a rectangle is the sum of twice its length and twice its width. Number 2. D is equals to R time. This can be translated into the distance traveled by a moving body is the product of its rate and time elapsed. Let us now explore one of the other examples of problems involving rational algebraic expressions. The example is speed travel problem. An object is said to be in uniform motion when it moves without changing its speed or rate. This example using a formula of distance. So D is equals to R times time. Example, Maki won a 2-day bicycle race. He traveled 60 kilometers each day, and his average speed on the second day was double that of the first day. If Maki rode for a total of 6 hours, what was his average speed each day? Step 1. Let x is equals to speed on the first day. 2. Make a table. And step 3. Write the equation. Step 4. Solve. 60 over x plus 60 over 2x is equals to x, and that is the equation. Second one, 60 over x plus 60 over 2x is equals to 6. Multiply both sides by 2x, the LCM of x and 2x, and then distribute properly. Next, 120x over x plus 120x over 2x is equals to 12x. Next, 120 plus 60 equals 12x. Simplify. 180 is equals to 12x. Combine like terms. 180 over 12 is equals to 12x over 12. Divide both sides by 12. Then the result is 15. Hence, the speed on the day 1 is 15 km per hour and day 2 is 30 km per hour. Now, in step 5, substitute the number 15 to the x so that 60 over x plus 60 over 2x is equals to 6. Substitute the number 15 into the x. 60 over 15 plus 60 over 2 times 15 is equals to 4 plus 2 equals to 6. And that's our examples in speed travel problem. Now, let's proceed to the application in order for me to know that you understand our topic. In application, translate each verbal phrases into an algebraic expression. You must answer this in 10 seconds. So number 1. In number x subtracted from 5. Number 2. Twice the product of 4 and 1. Number 3. A number n divided by 6. And number 4, 5 times the number of x. Okay, time's up. Now, let's proceed to our evaluation. This activity, it serves as your attendance. Okay? So, activity 3, name how fast am I? A passenger train can travel on average 20 miles per hour faster than a freight train. If the passenger train covers 390 miles in the same time, it takes the freight trains to cover 270 miles. Then how fast is each train? Okay, I guess we are running out of time. Please pass your paper. Finish or not finish. Okay, thank you. And goodbye, class.